chili update. It is now an edible temperature, not an Oedipal, like an Oedipus complex, like an edible. It is not too hot to put into my tummy. Um, we could model the cooling of my chili with a logistic graph of some sort, or negative decay graph, or radioactive decay, or something like that. I don't know. Let's talk about it when we get into the logs and exponents unit. Too much for now. Anyways, well, finally, we get to use a graphing calculator, which is sweet. So let's use it. If f of x equals the cube root of x minus 4, and g of x equals x squared plus 2, part A says, yo dude, what is f of g of x? Well, f of g of x is a composition of functions. It says, take the function g of x, the entire function g of x, that x squared plus 2, and rewrite that inside of the f function in place of that x. So, yes, I will do that. I always listen to functions when they tell me to do things. So I need to start off with my cube root function for my blue f of x function. And then notice the first term inside my cube root is x. So instead of writing x, I need to write the entire g function, which is x squared plus 2. And then I need to finish off the rest of my f function, which is minus 4. And once I've done that, I should go through, and I should actually simplify this as the cube root, which I'm going to use a power of 1/3 to write. I don't know why, I just like it so much more. I'm going to do that, and inside I'm going to have x squared plus 2 minus 4 is minus 2. And that is my f of g of x function right there. Now let's do g of x. Let's do the opposite of what we did up here. Now I'm going to take the entire f of x function, and I'm going to shove that inside the g function in place of that x. But be careful. Do absolutely not forget to put the entire function inside parentheses, because you have to be squaring that whole thing. So let's do it. So I'm going to start writing my g of x function, which happens to have a starting term of x squared. So that tells me I need to start by writing my f of x function inside parentheses, of course. So I'm going to have the cube root of x minus 4. Let's close off those parentheses. That's squared from that original function square, and we need to add 2 to it. But I'm going to simplify it more, because again, I love fractional exponents. And this is the absolute same as the quantity x minus 4 raised to the power of 2/3, because whatever that power is right there, that's your numerator of your fractional exponent, and the denominator is whatever root you have. So that's how we get the 2/3 right there. So I have my f of g of x function, I have my g of f of x function, and now I'm told to find where f of g of x equals g of f of x, which is a fancy way of saying, hey, for what x values do these two functions have the same y values? Which is another fancy way of saying, hey dude, graph it on your calculator and find the intersection point. And look, I was even nice enough to tell you that there are actually 2 values of x. Wow, cool. Let's do it. So enter these 2 functions into your calculator. Alright, so I paused to take some screenshots of my calculator, and some things happened. First off, my dog opened my door and came in my room and jumped on the bed. So at first I was like, oh, that's so exciting, because I like my dog. And then she started to kind of come closer to me, which was even more exciting, because I like when my dog is close to me. But then I noticed she was actually licking her lips and walking towards my chili. So she didn't actually want me at all, so I kicked her out. Anyways, you should enter your two functions, f of g of x and g of f of x, into your calculator. They should look like this, unless you are on a TI-83 or an older 84, in which case they should look like this, parentheses, x squared minus 4, close parentheses, caret, parentheses, 1 divided by 3, close parentheses. And if you do not put that exponent in parentheses, your function will be incorrect. Unless you... Oh, I did this backwards. I should have done that blue. My bad. But if you forget those parentheses on an older calculator, or if you don't use parentheses when you're doing a denominator like x minus 1, if you just type like x, or like if you type your function divided by x minus 1, it'll be incorrect. You have to put it in parentheses. When in doubt, use a bunch of parentheses. So our second function should look like x minus 4 in parentheses, caret, parentheses, 2 divided by 3, close parentheses, plus 2. And that should do us. And then, again, since we don't really know where this function is going to be intersecting each other at, it is a good idea to start with a standard window, see what happens. So that's what I did here. Started my standard window, and if you notice, I've got my red graph, which is my 2/3 bird graph, and then I got my blue graph, which is kinda, almost, sorta like a hyperbola function, but like weird and super not like a hyperbola at all, because it's a cube root instead of a square root. And like that's negative, which is also kind of super weird. But anyway, it ends up looking like this blue graph, which is pretty cool, and is totally not even though it super looks like it's even. I think you'll find that it's not an even function, unless I'm mentally being silly right now. But anyways, we're trying to find these intersection points, and if you look, something's going on in there, but I don't know quite what, because it's kind of small. So what I want to do is I want to zoom in on that. And when I say I want to zoom in on that, I don't mean use the zoom in feature. I mean use your brain to figure out where that is happening. My x scale is going by ones, which tells me each of these tick marks is 1. So I know that the hot zone right here is happening from 1 to an x value of 3 up to an x value of about 5, or if you're scared, 6. And my y values look like they're happening about like 2 up to, I don't know, 4, somewhere in that zone. So adjust your window. I adjusted mine. And then look, you can actually tell that we do have the bird graph going on. It's got the little cool V. And on top of that, pretty neat, we can clearly see these two intersection points right there. And so, hit second, calculate, takes you to this screen. We want to choose intersection, and then follow the prompts on the screen to find the two intersection points. And you should find the values x equals 3.815 and x equals 4.507, and we are done.